I would now like to turn over this presentation to our speaker, Carm. Carm, the floor is yours.
Thanks so much, Danielle, and welcome everybody. So great to be here. And today we wanted to talk a little bit about focusing on operationalizing generative AI models to increase competitive differentiation. So first, we'll start with a conversation around unleashing the AI potential. Then we'll move into driving efficiencies and return on investment, because any time that we sort of move into this arena, we want to ensure that we're making investments that do have a return. This is really important to us. And then we can talk about some real world case studies, and as well as what are some best practices and pitfalls that we might want to be careful of or aware of so that we don't get caught up in these kinds of situations. All right, so who am I? So I am our Chief Data Officer here at Insight for North America and a distinguished engineer, and I run our portfolio around data and AI, and I've been in the industry for quite some time. So I've seen a lot of the AI phenomenon occur over the last 25 or so years. And I also teach at Northeastern University, where I focus on cloud computing, as well as data science and other areas related to the kinds of things we'll be talking about today. All right. So one of the areas where we've been seeing the most traction today has been focused on around OpenAI and Microsoft's ability to be able to provide these capabilities to their customers by using a local tenant. And one of the concerns for a lot of organizations was always the fact that we wanted to be able to use OpenAI, but we didn't want to use it in the public domain. So we wanted to be able to use it in a protected way so that we could secure our data. So we didn't have to expose our information externally. So there are a number of different capabilities that Microsoft provides to us, and they were the leaders in the market in terms of providing these capabilities. Now, of course, over time, there's been a lot of other organizations that are providing some of these similar capabilities, but in general, Microsoft's still leading the way in terms of capabilities, building co-pilots, and other areas of focus. And there's a variety of them as well. We won't get into too much into this area, but in general, just know that there's clearly a lot of capabilities around code generators, around different variants of the GPT model, as well as images from text prompts, for example, that you can generate. All right, so Microsoft as a focus area here, just in terms of leading the way, we really want to think about two primary areas. Cognitive services is really important for us to be able to understand how to leverage the knowledge that we will have curated within the organization, and then make it available to be able to use it in other services that we might be deploying within the organization. And then also Azure Applied AI services, which are, I'll call them more solutions focused, which help us to be able to do things like, for example, creating bots or immersive reading capabilities, et cetera. So the combination of these services and service capabilities allow us to be able to do things more effectively. So think of this as sort of the background by which we can create our solutions, and those solutions should be targeted at creating customer value within your own business or for your customers. And so that's really what it's all about. So what is the impact that you're looking to focus on, and what are some of those areas where you can leverage these capabilities in order to provide those solutions? So where I'll start is really just related to this concept of a generative AI lifecycle. So if you think about creating a solution, we first want to start with something that describes the goals. So what are the business challenges we're looking to accommodate for, or that we're trying to target? So that's where we always start. And this is very much similar if you're familiar with the machine learning lifecycle, or I'll call it the precursor to this, which was the also call it the classic AI lifecycle. But we did a similar kind of thing, and I've adjusted it to be able to support the generative AI lifecycle. And you'll see some differences if you're familiar with the classic ML lifecycle. But it always starts with defining the business challenge and also understanding what those goals are. So let's just kind of walk through this quickly, and then I'll get into some details in terms of how we can use this sort of a cycle to be able to understand our problem domain, but also then to successfully deploy our solution. So the next step that we would follow after we've created this set of challenges and define what the goals are to address those challenges, then we want to determine which generative AI model might be most appropriate. or what base model might make sense. So even in the Microsoft arena, we've already seen the fact that there are two different models. One was GPT 3.5, the other is 4.0. And I'm sure at some point in the future, we'll have GPT 5.0. It'll be out probably in the next several months. But there are also other models that are becoming more available. And even in the Microsoft platform, we can see other models which are being supported. So we might support Llama, for example, or other types of models that are being provided either through open source community or other providers that can be available within your Microsoft tenant. So picking the right type of model is really important because within that context, it really helps you to address your problem. It's not just a matter of parameters, but it could also be cost profiles. That might be something to take into consideration. So model selection is important. So we start with a base model. Next, we'll do some exploratory response analysis. Instead of, you might be familiar with the term exploratory data analysis, but now we're talking about exploratory response analysis. So what does that mean? That basically means, am I getting the right type of responses that I would have expected? So in essence, when we train a generative AI model, or the model has been trained, remember GPT stands for Generative Pre-trained Transformer. So the pre-training part of this really means that it's been pre-trained on a set of tasks. So based off of those tasks, is that model able to support the exploratory response analysis that you're looking to provide? So here's where you would test it out first to see, is it familiar with the kinds of tasks I'm asking it? Now, you may not have all the knowledge yet, but we'll get to that in just a minute. So the next step is to focus on the large language model engineering technique that you might use. So this has to do with, how do I insert knowledge into the arena so that I have the ability to execute on those tasks that the model can support? Because of the fact that within your organization, you have collected all the knowledge that you may want to use to be able to drive that model, but it's not available, obviously, to the pre-trained model that was given to you, or the one that was supported by within your Microsoft arena. So this is where we can say, insert our own knowledge. So which technique might be the most appropriate? And we'll talk about some of those in just a minute. And then the next step is to focus on large language model augmentation creation model. So we might say, maybe it's prompt engineering that is going to be the technique that we want to use. And then we'll determine which approach works best for us. Do we want to use a RAG model, for example, or do we want to just assume that the end users can type their own prompts in to be able to set the context? So each one of these techniques has different strengths and weaknesses. You need to make that determination. The next step focuses on is the approach addressing your specific needs. So in this context, are you able to, we've done some exploratory analysis up to this point, but now, given the fact that I'm using those techniques, is it able to address the specific needs? And so here I want to do some testing to ensure, let's just say I did build, say, a vector database through cognitive services. Is it able to support the kinds of needs that I might need for my particular goals that I would have set in the first stage? This is where you can do some of that testing. And if it doesn't, then you go back and you determine, maybe I'm making some modifications in order to be able to get there. The next step then is it ready for business use? So you finally get to the point where it's like, I've run through all my test cases, I really do understand, or I've maybe done some testing with my stakeholders to ensure that it is ready to go and released into production and I can test this out with my business users. Maybe you create a test suite of applications where you move from, let's just say, test to production by running these particular use cases and ensure that the responses are what you expected. And the last part is, does the model continue to provide value? So this is the monitoring concept. So like we would look for erosion in a classical machine learning model, for example, this is where we want to ensure that we're collecting information to ensure that the large language model is still supporting the objective that we anticipated, and we want to have a measure to be able to do that. So this is where we can monitor the responses to ensure that they continue to provide a satisfactory response environment for the end users for the business purpose for which we created them. And that's really what we wanted to be able to monitor. So this is that modeling process. And then based off of that, if things do start to erode, then we could start over again. We could look at the challenges and verify any one of these steps in order to ensure that we can make adjustments to ensure that we are creating the most efficient model possible to be able to respond to the business user's needs. Okay, so I just want to drill into just a couple of these areas. So when we talk about building models, there are a couple different techniques. I've already mentioned one of them. So the first one is retrieval augmented generation, or RAG models. So this is the ability to use your own data to be able to insert it into, or I'll call it inject it into, the prompt stream so that it allows you to be able to set context. Okay, so this is really one of the more popular techniques that we might use in order to be able to quote unquote chat with our data. So this is how you can provide knowledge to the underlying large language model in order to be able to provide that knowledge or context to be able to issue the kinds of queries that you expect, or prompts, so that you can get the expected responses. Okay, so this is a very popular technique, probably one of the more frequently used ones, because not only is it simple, but it also allows you to be able to then be very flexible with the types of knowledge that you might want to curate and provide to your business as you think about the overall process. The next one is called fine tuning. Now, this is a little bit more complicated because what happens here is you're fine tuning the underlying model itself. All that really means is you're changing some of the parameters that allow you to be able to, or at least allows the model to be able to respond to your prompts. Think of this as like sort of baking in some of capabilities into the model itself to be able to understand with more clarity the kinds of tasks that you might be asking the model to do. So, or even baking knowledge in, for example, that might be more appropriate for your particular use case. So fine tuning can be a little bit more complicated, and there's less activity here because of the fact that it's like, in order to be able to do it, it requires some additional expertise to be able to fine tune your own model, but it also means that you have the susceptibility or potential for overtraining your model in a specific area, in which case then this is a term called forgetting, where the model may forget how to perform other tasks because you've overtrained it for one particular task of your own. We won't get into this in too much detail, but just be aware that that's some of the challenges that might exist with fine tuning. And then finally, for very specific areas, you can actually start and train your own model. So you might have situations where you want to use your own data and train a model or a large language model on your own data, create your own event space, and release it from scratch. This is a much heavier lift because you have to now have all of the data that would be required in order to train the model on specific tasks. And this is, you can think of this as large organizations, say, training a model, which let's just say, for example, Meta has done this. So they released their own model, and they have the ability to do this because they have their own corpus of data with which to train it, and they can release their own set of models. Google's doing something similar, as well as AWS and NVIDIA, for example. So those are sort of large scale offerings, which are coming from, I'll call them large vendors, but it's a bit of a heavier lift, but you can do that on your own if you really wanted to. Also, we want to think about when you're deploying a model. What are some of the challenges that you might think about here? Well, cost management. So consider the costs of the entire ecosystem. You pay by the token typically for the models that are being released on a service-based orientation. So here you have to think about, well, what is it costing me in order to be able to apply or use the model? And if you're using a technique that does require, say, a lot of prompt embedding, then those tokens actually could be significant in terms of your cost. Anytime that you think about using some kind of a prompt embedding technique, you also have to think about things like security. So you have to think about the security of your data, not only in the context of the data itself, which is stored in your cognitive services database or your vector database, but also then prompt security. So anytime that you are, say, making a prompt, or you're creating a prompt, or the response back, you do have to worry about the security of the environment. So those are potential areas where you can be exposed to, it's called poisoning or leakage of the actual prompt streams. So those are some areas to also keep in mind. And then I talked earlier about feedback. So feedback collection systems, binary feedback, for example, getting responses to the prompts or detecting things like hallucinations are critical in terms of monitoring the production environment. And then also, how much chat retention do you have in history to be able to go back and monitor over time? And you might even want to consider situations where maybe you want to perform forensic analysis. So you might keep prompt history for that, of course, securing it so that you don't end up with susceptibility of sensitive data being exposed. And then finally, operationalizing models. So getting to the point where you're able to operationalize these models so that you can create experimental environments, so that you have the ability to understand where you can make fine-tuning adjustments and also understand how to make the environment more efficient. And then you can also use this for being moving from a proof of concept environment to be able to move something more production scale and viable, or having a direct impact on your business. We also want to think about scaling generative AI implementations through something like centers of excellence, where you can say there's a disciplined approach to be understanding how this life cycle actually does work, and then how we can support this overall. So creating a center of excellence around generative AI is another critical component to think about, sort of the fruition of the overall life cycle. So these can become really important considerations for you as you go through the overall process. So let's talk a little bit about how we can help. And so within the context of the way that Insight thinks about these problems, we like to start small and accelerate, and then move into enterprise-wide implementations, and then governance and management, as I was just describing, things like a center of excellence, for example. So the idea here is to move from value creation to value realization. So when we start this and we think about what are some of the goals that we might apply in the beginning parts of the life cycle, how do we first understand, is it addressing our particular needs within the organization and the challenges, and then moving it to more production scale and true value realization when we're able to monitor the environment and then tune it to be able to address those very specific needs. So these are important considerations, and the timeframes are important too. So we can start with things like, for example, quick briefings or security workshops or strategy workshops, sorry, where we can talk about, this is our approach. So we can start within days of effort and initiative to be able to just understand what is it that we want to accomplish. Then we can move into an acceleration phase where we think about, how do we deploy a solution quickly so that we can start to iterate on what some of those solutions might be, and then move into an enterprise-wide transformation model where we can say, now we moved into production, and we can take advantage of some of the investments that we would have made, and then realizing that value as we start to move more toward the enterprise. And then finally, in governance, where we create centers of excellence, and we allow ourselves to be able to take advantage of that value and continue to then evolve over time, really taking advantage again to the realization of the fact that not only are we pulling out a lot of that value that we would have created, but we're able to make it a more sophisticated environment and optimize our production over time. And then finally, we have complete data and AI capabilities, so we can focus on just really alignment toward the overall objective. So artificial intelligence, modern data platform, business intelligence allows us to be able to create the kinds of environment that you would require in order to be able to create success within this area. And then finally, overall, we've had a lot of experience in the Microsoft domain. We have complete data and AI expertise. We're a full solutions integrator. And then we have accelerators that allow us to be able to move faster within the context of being able to deliver. So when we get into the acceleration phase that I was describing earlier, we have accelerators that allow us to move fast, realize value quickly, so that you can actually get up to speed running quick. And if you're interested, then scan the QR code, and we would love to speak with you further on how to create a solution.